So hi guys, welcome to my channel. So today I'll be solving the GFG problem of the day, which is minimal cost. Okay, so let's read the problem and try to approach this. But again, the difficulty is medium. But after I explain this approach to you, you will be very clear that how recursive calls are going and how this approach is working. Like this is the standard problem of recursion. Okay, so let's read the problem and try to approach this. So there is an array ARR of heights of stones and geek is standing at the first stone, okay, and can jump to one of the following stones. Means if geek is standing on I, he can jump to I plus 1, I plus 2, I plus 3 until I plus k. K will be given to us, okay. Here you can see k is equals to 3, okay. So now where k is the maximum number of steps that can be jumped and the cost will be hi minus hj is incurred. Incurred means can be taken, okay. So where j is the stone to land on, okay, find the minimum possible total cost incurred before the geek reaches the last stone, okay. Okay, so let's try to understand this with the help of this test case, okay. So let's say if we are standing at 10, okay, so if the geek is standing on particular index, so the geek can take index plus 1, index plus 2, because the maximum geek can move is 2 steps. Okay, done. Okay, so let me write. Okay, so if geek is standing on this index, geek can take this step, this step. Okay, so if geek will take this step, what is the cost incurred? Okay, so it will incur 30 minus 10, absolute value of 10 minus 30, whatever you can take, but it will be 20. Okay, so let me write it 20. Now geek is standing here, okay, geek is standing here, okay. Now whatever what are the steps geek can take? Geek can take jump to this, geek can jump to this. If we jump to this index, 30 minus 40, which is equals to 10. Now geek is standing on this index, okay. Now whatever steps geek can take, geek can jump to this and no other options because this is out of bound, okay. So 40 minus 30, which is again equal to 10, okay. The cost will be 40. Now let's take one more step, okay. Now geek can jump to this or geek can jump to this, okay. So I have taken this step, okay. Let me take this step, geek can jump to 40. If geek can jump to 40, so our like cost will be 40 minus 10, which is equals to 30, and geek is standing here, okay. Now geek only have one move to jump, okay, from 40 to 30, which the cost will be equal to 10, which is again equal to 40. Now let me give you one optimal answer. From I geek can take one step, which is equals to 20, okay. Now if geek is standing here, again geek has two options, whether he can go to this or he can go to this, two steps, either one step, either two step. If we are taking the two step, so geek will directly reach here. So 30 minus 30, which is equals to 0, so it is equals to 20. Now our geek is standing here, and what we have to tell, if geek is standing at this position or the starting position, what is the minimum cost which geek have to incur so that he can reach to the last index, okay. So I hope the question is clear, and you can see that the answer will be 20, okay. The minimum cost geek can have is 20, okay. So what is the approach we have to follow? Okay, so at every index we have to explore k options, okay. If we are standing at this index, whatever jump geek can take, okay, whether it will be this, it will be this, or whatever k index we can go, okay. So by this we can understand that this is the problem of recursion, because we have to explore each and every options and then have to find the minimum, okay. We are standing, geek is standing at this particular index, okay, 10. Now we have to explore k options, okay. So first what we'll be doing, we'll be doing a loop, because we don't know in this options we have k is equals to 2, but k might be equal to, like you can see, what is the constraint for k might be equal to 100. So if we are standing at index, k can jump to 100 steps, okay, this up to 100, okay. So we have to make a for loop, okay. We are making a for loop for steps from 1 to k it will go, okay. Just remember this thing, okay. So let me do the try run. Let's say geek jump one step, I is equals to 1, index plus 1, which is equal to this index 30, okay. Means geek is standing on 0th index, index plus 1, which is equals to first index. Now what are the cost Geek will incur? This. Okay, so we'll be keeping it in temp, because finally we have to compare it and return that whatever the, okay, I'll be saying that, okay, Geek, I'll be giving you freedom to take one step. Now it's your duty to explore further options and tell me that what is the minimum like cost we can get. Okay, so I hope this is clear. Now what is the cost we can get? Okay, so 30 minus 10, which is equals to 20. Let's say it is 20. Now I'll be saying that, okay, now Geek has taken one step. Geek is standing to 30. So it will be 10 comma 30 comma 40 comma 30. Now what is the index Geek is standing on? This index, because index plus 1, 0 plus 1, which is equals to 1. Now Geek is standing on 30. Now what are the options Geek can have? Again it will do the for loop. Okay, k options means 1 and 2. Again the for loop will run. Okay, so if for loop will run, so we'll be exploring I is equals to 1. Okay, just bear with me till the end and you'll be very clear that how recursive calls are working, and this pattern is very important for you all to understand, because you all can see that this types of pattern like it is observed in CSES, AdCoder. If we are standing at this index, now Geek is standing at 30. Now again Geek will first explore the one step option. Okay, so again this will temp. Okay, so temp. Now if Geek will take one step, so 40 minus 30, which is equals to 10. Okay, so it will equal to 10. Now 10, 30, 40 and again 30. Now where Geek will stand? Okay, Geek will stand on this index because Geek has taken one step. Okay, let's just move, and every time we will be storing our answer, because whatever calls we are making, let's say k is equals to 1, k is equals to 2, k is equals to 3, k is equals to 4, and let's say 100, whatever will be the minimum among all these, we'll be storing it in our answer and returning back to this. Okay, I hope this is clear. Now Geek is standing on this index 0, 1, 2, second index. Now again for loop will run. Geek will take one step. Okay, okay, so now what is the temp? Temp is equals to if Geek will take one step, absolute value of 40 minus 30, which is equals to 10. Our cost will be 10, and I'll be saying that Geek go and explore further. Okay, 10, 30, 40, and then again 30. Okay, our Geek will be standing on this index. Now if our Geek is standing on this index, so we have no other options to explore further, so I'll be returning 0. This is our base case. Means if our Geek, because if our Geek is standing on this index, so I have already calculated this pair 40 minus 30, which is equals to 10, and go and further explore. So if our Geek is standing on last index, then it means that we have no other options to explore. So the call will go again and it will hit the base case. Okay, BC. Okay, by the way, this is not the BC which you all are assuming. This is the base case. Okay, so jokes apart. Now, if we hit the base case, what we'll be doing? We'll be going back and returning 0 because there is no further options. So if there is no further options, then there is no cost incurred. So it will return 0. Okay, so now every time we'll be storing our answer. Okay, done. Every time what I have said, it will run a for loop. In the for loop, for first go I is equals to 1, we have calculated that we got 10 plus 0. Okay, done. Now we will go for another options, means I is equals to 2, because we can take k is equals to 1 step, k is equals to 2 step. K is equals to 1 we have already explored and we got 10. Okay, now if k is equals to 2, if k is equals to 2, then it got out of bound. Okay, it means we have to make a check condition that whatever index, whatever step we are adding in the index, it should be in the range of array. Okay, so the call will not go. Okay, if the call will not go, so we can say that what is the minimum among all these steps. Okay, we have, if Geek is standing on this, Geek will tell that, oh okay, go and explore all other options and tell me the what is the minimum step we can, okay, minimum cost I can get. Okay, so Geek has explored this option, Geek has explored this option. What is the minimum? Minimum is 10. Okay, so the answer will be storing equal to 10, and finally return that, okay, the minimum cost I can get from below options is 10. Okay, done. Now I have got 10. Okay, from below I have got 10, and for current step I have got 10 plus 10, which is equal to 20. Okay, till now, if I have told, if Geek is standing on this index, Geek will tell, okay, take one step and explore. Okay, I have explored and I got 10 plus 10, which is equal to 20. From this part I got 20. Okay, now explore other options also, because you have 2 steps remaining. Now the Geek will take I is equals to 2. Okay, if Geek will take I is equals to 2, then temp is equals to what? Take 2 step means 30 minus 30, which is equals to 0. 0 plus Geek will be told that, okay, 10 comma 30 comma 40 comma 30. Now Geek will be standing at this position, because initially Geek is at 30. Now after 2 it will again stand at it will be standing in the last index. Now if Geek is standing on the last index, then we have no other options to explore, so the base case will hit. Okay, again BC, base case will hit, it will get back and give 0, because if there is no other options, we have no extra cost. Okay, so 0 plus 0 is 0. Okay, from this option we got 0, from this option, okay, from this option we got, okay, we got 20. Okay, so what is the minimum among 2? Okay, if Geek is standing at this position, and if it take 1 step, I'll be getting 20 cost. Okay, if Geek will take 2 step, I'll be getting 0 cost. So obviously I'll be taking with 0 step. I'll be updating answer is equals to minimum, which is equals to 0. Okay, so now what it will be returning from below call, it will be returning our answer, means it will be returning 0. Okay, so if Geek is standing at 0th index, it will be, say that, okay, go and explore further options and give me the answers. Okay, so till now I got 20 plus 0. Okay, so this option is giving me 20. Okay, done. Now Geek will say that, okay, you have explored 1 step, now it's turn to explore the 2 step. Okay, I is equals to 2. If I'll be exploring I is equals to 2, then temp is equals to, if Geek is taking 2 step, means 40 minus 10, which is equals to 30, plus, now where Geek will be standing? Geek will be standing on second index, means at 40. As you all can see that Geek will be standing here. Okay, so now the call will goes like this. Okay, so again below we have I is equals to 1. If Geek is standing on this index 40, I is equals to 1 step. If it will be taking 1 step, then temp is equals to 40 minus 30, which is equals to 10, plus 10 comma 30 comma 10 comma 30 comma 40 comma 30. Okay, Geek will be standing here. We have already calculated this pair. Okay, 40 minus 30, 1 step taking. Okay, so if Geek came to like end of this, so it will hit the base case. And what we'll be doing, if we are at the end of this like array, we'll be returning 0, because there is no other options to explore, and if we have no other options to explore, we will be returning 0. Now 10 plus 0, which is equals to 10, is like Geek has any other options to explore I is equals to 2 step? No, because it will be going out of bounds, so it will be like it will not be exploring other options. So our answer will be 10 plus 0, which is equals to 10, finally returning above 10. So 30 plus 10, which is equals to 40. Okay, I'll be getting 40. Now let's see. Okay, here, from here we got 40. If Geek is standing at this index, Geek will be saying that, okay, go further and explore and give me the minimum possible cost. It has explored this path, it has explored this path, further path were explored, but from this path we'll be getting 20, from this path we'll be getting 40. What is the minimum? 20. So answer will be equal to, answer will be storing the minimum, which is equal to 20, and finally we'll be returning 20, and at above it will return 20. It means that if Geek is standing at this particular index, what is the minimum cost Geek can incur, which is equal to 20. Now someone will ask that, what is the path you have taken so that you have got the cost of 20? Okay, so let me tell you that among 20 and 40, from where we have taken got the minimum. Okay, this side we have got the minimum. 20 means taking 1 step. Okay, then include 10 and 30. Okay, done. 10 comma 30. Let me include only one step which the geek is standing on. Okay, 10. Now I have came here. Okay, so if we are standing on this step, what is the minimum cost we have got, and from which path we have got? Okay, from here we have got 20, here we have got 0. Okay, so we have to move here, but before that I'll be including the current geek where geek is standing. Okay, I have included 30. Now we are standing at 0. Okay, so if geek is standing at 0, from where we have got the path? Okay, so this is the base case we have hit. So what we'll be doing, I will be including the like where geek is standing. Okay, so geek is standing again at 30. Okay, so now you can observe that from 10 we have visited to 30, and from 30 we have visited to again next like the last index. One step, two step. So 30 minus 10, which is equals to 20, and 30 minus 30, which is equals to 0. So that's how we have got the answer as 20. Now, what is the time complexity for this problem? Okay, so let's see the time complexity for this problem. Okay, T dot C. Every time what we'll be doing for each and every index. Okay, this is the like every index of the array. For every index, I'll be exploring k options. K options. Dash dash dash. For every index I'll be exploring k options. Let's say our array contains n number of integers, then what will be the time complexity? K to the power n, means if I simplify it, k into k into k into means n times, so it will be equal to k to the power n, and our space complexity will be equal to big of n. How? Because you will be saying that I haven't used any data structure, but you are using the recursive call stack where it all storing the all the like temp, answer, again call this one. So where it is storing? It will be storing in the recursive call stack. Okay, but you all can see that the constraint is very high, means k is equals to 100 and size is 10 to the power 4. Okay, so k is equals to 100 means 100 into 10 to the power. Okay, so 100 into 10 to the power 4, which is very big. So it was not going to pass it in the like 1 second, because in 1 second I can say that roughly it will pass 10 to the power 7 to 10 to the power 8 iteration. So how we can optimize it? We'll be using the dynamic programming. Okay, so how we'll be using the dynamic programming? What we'll be doing? Okay, so before that let me show you the code of recursion. Okay, so this is the recursion we are doing. So what we are doing is we are making the solve function and pass the 0 index, because at first our geek is standing at 0 index. This is the k value which geek has to like explore all the options, and I have passed the array, same the index, the k, and the vector array. Now if index reach to the end of the array, means array dot size minus 1 at end, what I have told you, I'll be returning 0. Done. At every recursive call I have initialized an answer variable. Okay, at every recursive call answer variable, here also answer variable. Okay, done. Now what we'll doing, I'll be exploring each and every step. Okay, and making a check that if I am okay. So what this for loop is explaining, this for loop is saying that I'll be exploring I is equals to 1 till I is equals to k step, means total k step I'll be exploring for each and every index. Okay, done. If I'm standing on index and if I have included this, it should be in the range of array dot size. It should not go beyond array dot size. So I have included one check. Okay, so at this step I is equals to 2 is going out of bound. So for that I am making a check. Now every temp variable I have included the answer and told him to go and further explore. Okay, for temp variable what I'm doing, okay, so let me tell you in very short. Temp variable I have included the cost and told the recursion to further explore, and if recursion has further explored and give me the option, then what we'll be doing, okay, this temp has already given, this temp has also given. Now I'll be comparing and storing it in answer as the minimum cost of what I have got. Okay, so every time I am like storing the minimum cost in it. Okay, and finally I got the, after completing the loop, means after completing all the step like this one and this one, both step, I'll be like in our answer variable the minimum cost will be stored, and finally I'll be returning it. Okay, so I have returned the answer, and this is how we are solving this problem. Okay, but it will give the TLE because the time complexity is like the time complexity which I've explained is k to the power n exponential, so it will not pass. Okay, you all can see that this is given clearly. So let me explain you one thing. Okay, so what we'll be doing, we'll be storing all the previously calculated answer in our DP table. Okay, so let me write the code and you'll be very clear. DP of size plus 1 comma minus 1 means initially I have filled the DP table as -1. Okay, done. Then DP and then passing here comma DP. Now if DP of index is not equal to -1, it means I have initially filled the DP table as -1. If the DP of index is not equal to -1, means we have previously calculated this answer, so no need to go for like repeated call, simply return the DP of index. Okay, DP of index. Okay, done. Now let me pass it in the solve function DP, and here while returning the answer, it means that if I'm standing on index and I have returned this answer, so store it in the DP table. Means if in further any calls I'll be getting that okay, Geek is standing on first index and answer is 0. If in any other call, if I'm getting the same condition that okay, if Geek is standing at first index and what is the answer, so I have already stored that answer is 0, no need to call it again. Okay, so I'll be storing it in answer index is equals to answer. Now let's run this. Means I have created the DP table, store the like calculated answer in the DP index. If DP index is not equal to -1, means we have already stored it in the answer like in the DP index, so directly return the DP index, no need to explore further. Okay, so let's submit it. Okay, so we have passed all the test cases. So this is how we are solving, and from this time complexity we have reduced the time complexity to big O of k into n. Okay, so this is the new time complexity for our problem, and the space complexity is still big O of n. Okay, so I hope the question is clear and the code is crystal clear. So thank you for watching and having patience. So thank you.